Hi students, welcome to JSR Maths Academy. Today we are going to discuss about surds of part 3. Surds of part 3. So before this part 3, in the part 2, we have discussed about some important laws of radicals. Now in the part 3, we are going to see that how we are going to apply that laws of radicals. So let us start our part 3 with the first example, that is of convert 2 by 3 whole to the power of root 2 by 3 into root 7 into pure surd, So we need to convert this 2 by 3 into root 7 into pure surd. So pure surd means what? That we need to understand. Pure surd means what? A monomial surd is said to be as a pure surd if the rational coefficient is 1. If the rational coefficient of monomial surd is 1. If you take a root b is a monomial surd, this monomial surd is said to be the pure surd. This can be said as a pure surd if and only if a is equal to 1. So here this is a monomial surd in which a is 2 by 3, which is not equal to 1. So that means we need to convert this into pure surd, means we need to make this rational coefficient as 1. To that, what are the steps that we are going to do? Let us see. So I am writing this 2 by 3 whole to the power of 1 into root 7, and 1 I can write it as an 2 by 3 I am writing as an 2 by 2 into root 7 can be written as 7 to the power of 1 by 2. Now this 2 by 3 whole to the power of 2 by 2 can be written as 2 by 3 whole square whole to the power of 1 by 2 into 7 to the power of 1 by 2 into 7 to the power of 1 by 2. Now if you observe this, a to the power of m into 8 b to the power of m is equal to 8 into b whole to the power of m. By using this formula, here this total is a, this is b. So this I can write it as an 4 by 9 whole to the power of 1 by 2 into 7 whole to the power of 1 by 2. So this I can write it as an 4 by 9 into 7 whole to the power of 1 by 2. By this I can write it as an 4 7s are 28 by 9 whole to the power of 1 by 2 can be written as square root. So this I can write it as an square root of 28 by 9. Now in this, what is the rational coefficient? Here rational coefficient is 1. That means I made this given monomial surd into pure surd by making the rational coefficient of this as a 1. So this is how to convert a monomial surd into pure surd. Okay. Now let us see the next question. In the next question, if they mention that in the next question they are asking us to convert a pure surd 50 by 4 into its simplest form. It is into simplest form. Simplest form means what? Rational coefficient is not a 1. Okay, if possible, we need to make the rational coefficient other than 1. So for that, what we supposed to take? Let us write the given number as easily. I am writing 50 by 4. Now you need to check that what is the order of this surd. Order is 2. It is not necessary to mention the 2 here. So though it is not mentioned, we need to consider it as the order 2. If order 2 means we need to try to write the given numbers. We need to try to write the given number as a square into something. That means, can we write a 50 as a perfect square into something? Means yes, this 50 I can write as a 25 into 2, where this 25 is a perfect square. So, and if you observe this, 4 is a perfect square. That means I can write it as an root 50 by root 4. Root 50 by root 4, where root 50 can be written as root 25 into 2 by square root of 4 is 2. Now on taking this, this I can write as root 25 into root 2 by 2. Then root 25, square root of 25 is 5. 5 root 2 by 2. That means, and this is a simplest form of, this is a simplest form of our given monomial surd. Okay, this is how to convert this into simplest form. Now, let us see the next question. Next question is that write the simplest form of cubic root of 24. Write the simplest form of cubic root of 24. If you observe this given number having 1 as a rational coefficient. So let us try to make that as a simplest form. So simplest form means if there is any other number can be removed from this third part or not, from the radical or not, that we need to see. Here, what is the order of this third? Order of the third is 3. Order means order is 3. If order of third is 3 means you need to write that 24 as a prime factors. That means I am going to see that can I write this 24 as a perfect cube into something. Can I write this 24 as a perfect cube into something? So 2 12s, 2 6 and 2 3s. That means 24 I can write it as a 2 cube into 3. So this I can write as a cubic root of 2 cube into 3. Now I can write it as a cubic root of 2 cube into cubic root of 3. Now by this I can write cubic root of 2 cube means what? 2 itself. 2 into cubic root of root 3. I can write it as a 2 into cubic root of 3. Now this is said to be what? The simplest form of the given surd, where the rational coefficient is not a 1. Where the rational coefficient is not a 1. Okay. Now we are going to discuss about addition and subtraction of the surds. Addition and subtraction of surds. Two surds can be added or subtracted one from the other by using distributive law. Only when they are similar. When they are similar surds. That means we can only add or subtract only similar surds. That means what? Means similar surds means what? The surds which are having same radical coefficients. That means if you take a root b plus c root b is that. So then here if you observe these two surds, first surd is having irrational coefficient as a root b and the second surd is having irrational coefficient as a root b. That means these two surds are having same irrational coefficients. So these two are said to be like surds. So these like surds can be added by using distributive property. That means on taking root b as a common, this I can write it as an a plus c into root b. That means a into root b plus c into root b is equal to a plus c into root b. Let us take a simple example on it. If you take 2 root 5 plus 4 root 5, these two surds can be added as a 2 plus 4 into root 5. So this we can write it as 6 root 5. Similarly, we can subtract the like surds also. So if you take another example, 4 root 3 plus 7 root 3 minus 10 root 3. If you take, now on taking root 3 as a common, the rational coefficients can be simplified as 4 plus 3 4 plus 7 minus 10 into root 3. That means 4 plus 7 is 11. 11 minus 10, 1. So 1 root 3. That is of root 3. That is of root 3. Which is of pure set here. Okay. Likewise, we can use radical laws and simplify them easily. Now, we are going to discuss a few more problems based on converting into pure sets. Okay. Converting into pure sets. First, convert. First question is that 3 root 2. Second question is that 2 into cubic root of 5. So convert these two into pure sets. Into pure sets. We need to convert this into pure sets. Okay. So if you observe the first question we have 3 root 2. So as we don't have a root 2, as we don't have a root for this 3, so let us try to write this in the form of root. So this root 3 can be written as square root of 9 into square root of 2. So we know that under root a into under root b can be written as under root of a into b. By using this law, I can write this as an under root of 9 into 2. Then you can write it as an root 8. This is said to be what? Pure set. Why? Because its a rational coefficient is 1. And if you observe this, 2 into cubic root of 5. Here what is the order of this set? 3. Order of set is 3 means we should write this as an third power. So for that we need to raise this power by 3 and divide the power by 3. So that means 2 to the power of 3 by 3, which is of 2 to the power of 1. See, 2 to the power of 3 by 3 means 2 to the power of 1 itself. That is of 2 only. That means without affecting the value, I raise the power 3 and divided by 3. And this I can write it as a cubic root of 5. Now this part I can write it as a 2 cube whole to the power of 1 by 3. And cubic root of 5 can be written as 5 to the power of 1 by 3. Now on this I can write it as 2 cube means what? 2 into 2, which is of 8. So this I can write it as 8 to the power of 1 by 3 into 5 to the power of 1 by 3. So that this I can write it as 8 into 5 whole to the power of 1 by 3. Then this can be written as 40 to the power of 1 by 3. So that this we can write it as a cubic root of 40, which turns into the pure set. Why? Because it is its rational coefficient is 1. So this is how to convert this given rational or sets into pure sets. And let us see the next bit, that converting into the simplest form. Converting them into simplest form. So for that simplest form, okay, we need to convert this given numbers into simplest form. Let me take a first question, that is of square root of 28, and next question is that fifth root of 288. Okay, so here we have first question as that square root of 28. It is in simplest form already. Sorry, it is in pure set. So we should try to write this into mixed set. For that, what we need to do is we need to observe the order. Order is 2. Order is 2 means we should try to write this 28 as a perfect square into something. That means can you write as a 28 as a product of a perfect square in an other number? That means 28 can be written as 4 into 7, in which 4 is a perfect square. 4 is a perfect square, 2 square. So that I can write it as this. I can write it as a square root of 4 into 7. Square root of 4 into 7. This we can write it as a square root of 4 into square root of 7, where I use the formula of under root of a into b can be written as under root a into under root b. by using this, I wrote and square root of 4 into 7 can be written as square root of 4 into square root of 7, and we know that root 4 can be written as 2 root 7. This is a set result simplest form of this given number. And if you observe this next question, in the next question we have given with fifth root of 288, fifth root of 288, and if the order is 5, we should try to write this as a fifth root of, we should write this as a product of fifth root of one number and other number. So let me write for that. Let me take the prime factorization of this 288 prime factorization I am doing. So for that, 144s and 272s, 236, 2 18s, 2 9s and 3 3s. That means 288. 288 can be written as 1, 2, 3, 4, 5. That means 2 to the power of 5 into 3 square. That means I can write this fifth root of 288. Fifth root of 288 can be written as fifth root of 2 to the power of 5 into 3 square. So I can write it as a fifth root of 2 to the power of 5 into fifth root of 3 square. Now this we can write it as a 2 to the power of 5 into whole to the power of 1 by 5 into fifth root of 9. So we can write it as a 2 into root 9. This is said to be what? Simplest form of the fifth root of 9 here. Okay, so this we can write it as a 2 into fifth root of 9. Okay, this is said to be what? Simplest form of the fifth root of 288. Now let us see the next bit. In the next bit, we need to simplify this by using by converting them into similar sets. Bit heading is what? Simplify. Simplify the following. By combining the similar sets. By combining similar sets. Let us take a first question. First question is that 2 root 5 plus under root of 125. We need to simplify it by adding similar sets. But that means what? We should try to write them into similar sets. So here as a rational coefficient is 2 and here rational coefficient is 1. So let us try to make the rational coefficient other than 1 for the second set. For that, can write it as 2 to the power of 5 and 125 can be written as f of x product of 25 into 5. That means 25 is f of x square. As the order is 2, I selected a f of x square. So for that, what I'm going to do, 125 I'm writing as a 25 into 5 and 2 root 5 plus this we can write as a root 25 into root 5. So 2 root 5 plus of root 25 can be written as 5 into root 5. Now on taking root 5 as a common, we can add a numerical coefficients as a 2 plus 5, which is of 7 root 5. So that's then on simplifying this given expression, we get the answer as 7 root 5. Now let us take the next problem in this bit. That is of 4 root 7 minus 3 into 2 to 252 plus 5 into 343. Now let us take first number as easily 4 root 7 minus 3 into 252. 252. What is the prime factorization of 252? Means 252 can be written as 36 into 7. 36 into 7 and plus 5 into 343. 343 can be written as 7 into 7 into 7. 7 cube is 343. Now we can write it as 4 root 7 minus 3 into root 36 into root 7 plus 5 into these two terms I'm taking 7 square into root 7. Now 4 root 7 minus 3 into root 36 value we know it as a 6 into root 7 plus 5 into square root of 7 square, that is of 7 into root 7. So on doing this we will get it as an 4 root 7 minus 18 root 7, okay, plus 35 root 7. Now these all are the similar sets. So and taking root 7 as a common, this we can write it as 4 minus 18 plus 35. 4 minus 18 plus 35 into root 7. So 35 plus 4, 39. 39 minus 18, that is of 21. Then on simplifying it, we can write it as 21 into root 7. This is how to simplify this search. Okay, now let us take one more problem, last problem in this part. Okay, show that 4 root 3 minus 3 root 12 plus 2 into root 75 is equal to 8 root 3. So we need to prove this. 4 root 3 minus 3 root 12 plus 2 into root 75 is equal to 8 root 3. So for that what we need to do, first is in simplest form itself, 4 root 3 minus 3 into 12, we can write it as a perfect square of 4 into 3 plus 2 into 75 can be written as 25 3s are 25 3s are. So 4 root 3 minus 3, I'm taking 2 outside, square root of 4 is 2 will come out. So plus I'm taking 25, that means I'm applying square root for 25, 5 will come out. So 2 into 5 into 3, so we can write it as 4 root 3 minus 6 root 3 plus 10 root 3. Now on taking this root 3 as a common, we can write 4 minus 6 plus 10 into root 3. So this is of 8 root 3, which is equal to RHS, Therefore LHS is equal to RHS. So this is how to apply the laws of radicals to simplify these answers.